Topography is the study of the shape and features of the surface of the Earth and other observable astronomical objects including planets, moons, and asteroids. The topography of an area could refer to the surface shapes and features themselves, or a description. This field of geoscience and planetary science is concerned with local detail in general, including not only relief but also natural and artificial features, and even local history and culture. This meaning is less common in the United States, where topographic maps with elevation contours have made topography synonymous with relief. The older sense of topography as the study of place still has currency in Europe. Topography in a narrow sense involves the recording of relief terrain, the three-dimensional quality of the surface, and the identification of specific landforms. This is also known as geomorphometry. In modern usage, this involves generation of elevation data in digital form. It is often considered to include the graphic representation of the landform on a map by a variety of techniques, including contour lines, hypsometric tints, and relief shading. Etymology. The term topography originated in ancient Greece and continued in ancient Rome as the detailed description of a place. The word comes from the Greek tau omicron, pi omicron, sigma, and gamma rho alpha, phi iota alpha. In classical literature, this refers to writing about a place or places, what is now largely called local history. In Britain and in Europe in general, the word topography is still sometimes used in its original sense. Detailed military surveys in Britain were called ordnance surveys, and this term was used into the 20th century as generic for topographic surveys and maps. The earliest scientific surveys in France were called the Cassini maps, after the family who produced them over 4 generations. The term topographic surveys appears to be American in origin. The earliest detailed surveys in the United States were made by the Topographical Bureau of the Army, formed during the War of 1812, which became the Corps of Topographical Engineers in 1838. After the work of national mapping was assumed by the U.S. Geological Survey in 1878, the term topographical remained as a general term for detailed surveys and mapping programs, and has been adopted by most other nations as standard. In the 20th century, the term topography started to be used to describe surface description in other fields where mapping in a broader sense is used, particularly in medical fields such as neurology. Objectives. An objective of topography is to determine the position of any feature or more generally any point in terms of both a horizontal coordinate system, such as latitude, longitude, and altitude. Identifying features and recognizing typical landform patterns are also part of the field. A topographic study may be made for a variety of reasons. Military planning and geological exploration have been primary motivators to start survey programs. But detailed information about terrain and surface features is essential for the planning and construction of any major civil engineering, public works, or reclamation projects. Techniques of topography. There are a variety of approaches to studying topography. Which method to use depend on the scale and size of the area under study, its accessibility, and the quality of existing surveys. Direct surveying helps determine accurately the terrestrial or three-dimensional space position of points and the distances and angles between them using leveling instruments such as theodolites, dumpy levels, and clinometers. Work on one of the first topographic maps was begun in France by Giovanni Domenico Cassini, the great Italian astronomer. Even though remote sensing has greatly sped up the process of gathering information, and has allowed greater accuracy control over long distances, the direct survey still provides the basic control points and framework for all topographic work, whether manual or GIS-based. In areas where there has been an extensive direct survey and mapping program, the compiled data forms the basis of basic digital elevation datasets such as USGS-DEM data. This data must often be cleaned to eliminate discrepancies between surveys, but it still forms a valuable set of information for large-scale analysis. The original American topographic surveys involved not only recording of relief, but identification of landmark features and vegetative land cover. Remote sensing is a general term for geodata collection at a distance from the subject area. Passive sensor methodologies besides the role in photogrammetry, aerial and satellite imagery can be used to identify and delineate terrain features and more general land cover features. Certainly they have become more and more a part of geovisualization, weather maps, GIS systems. False color and non-visible spectra imaging can also help determine the lie of the land by delineating vegetation and other land use information more clearly. Images can be in visible colors and in other spectrum. Photogrammetry is a measurement technique for which the coordinates of the points in 3D of an object are determined by the measurements made in two photographic images taken starting from different positions, usually from different passes of an aerial photography flight. In this technique, the common points are identified on each image. A line of sight can be built from the camera location to the point on the object. It is the intersection of its rays which determines the relative three-dimensional position of the point. Known control points can be used to give these relative positions absolute values. More sophisticated algorithms can exploit other information on the scene known a priori. Active sensor methodologies. Satellite radar mapping is one of the major techniques of generating digital elevation models. Similar techniques are applied in bathymetric surveys using sonar to determine the terrain of the ocean floor. In recent years, LiDAR, a remote sensing technique that uses a laser instead of radio waves, has increasingly been employed for complex mapping needs such as charting canopies and monitoring glaciers. Forms of topographic data. Terrain is commonly modeled either using vector-gridded mathematical models. In the most applications in environmental sciences, land surface is represented and modeled using gridded models. In civil engineering and entertainment businesses, the most representations of land surface employ some variant of tin models. In geostatistics, land surface is commonly modeled as a combination of the two signals, the smooth and the rough signal. In practice, surveyors first sample heights in an area, then use these to produce a digital land surface model in the form of a tin. The DLSM can then be used to visualize terrain, drape remote sensing images, quantify ecological properties of a surface or extract land surface objects. Note that the contour data or any other sampled elevation data sets are not a DLSM. A DLSM implies that elevation is available continuously at each location in the study area, i.e., that the map represents a complete surface. Digital land surface models should not be confused with digital surface models, which can be surfaces of the canopy, buildings and similar objects. For example, in the case of surface models produced using the LiDAR technology, one can have several surfaces, starting from the top of the canopy to the actual solid Earth. The difference between the two surface models can then be used to derive volumetric measures. Raw survey data. Topographic survey information is historically based upon the notes of surveyors. They may derive naming and cultural information from other local sources. While of historical interest, these field notes inherently include errors and contradictions that later stages in map production resolve. Remote sensing data. As with field notes, remote sensing data is raw and uninterpreted. It may contain holes or inconsistencies. Most modern topographic mapping includes a large component of remotely sensed data in its compilation process. Topographic mapping in its contemporary definition. Topographic mapping shows relief. In the United States, USGS topographic maps show relief using contour lines. The USGS calls maps based on topographic surveys but without contours, planimetric maps. These maps show not only the contours but also any significant streams or other bodies of water, forest cover, built-up areas or individual buildings, and other features and points of interest. While not officially topographic maps, the national surveys of other nations share many of the same features, and so they are often called topographic maps. Existing topographic survey maps, because of the comprehensive and encyclopedic coverage, form the basis for much derived topographic work. Digital elevation models, for example, have often been created not from new remote sensing data but from existing paper topographic maps. Many government and private publishers use the artwork from existing topographic map sheets as the basis for their own specialized or updated topographic maps. Topographic mapping should not be confused with geologic mapping. The latter is concerned with underlying structures and processes to the surface, rather than with identifiable surface features. Digital elevation modeling. The digital elevation model is a raster-based digital dataset of the topography of all a part of the Earth. The pixels of the dataset are each assigned an elevation value, and a header portion of the dataset defines the area of coverage, the units each pixel covers, and the units of elevation. DEMs may be derived from existing paper maps and survey data, or they may be generated from new satellite or other remotely sensed radar or sonar data. Topological modeling. A geographic information system can recognize and analyze the spatial relationships that exist within digitally stored spatial data. These topological relationships allow complex spatial modeling and analysis to be performed. Topological relationships between geometric entities traditionally include adjacency, containment, and proximity. Reconstitute of site in synthesized images of the ground. Determine a trajectory of overflight of the ground. Calculate surfaces of volumes. Trace topographic profiles. Topography in other fields. Topography has been applied to different science fields. In neuroscience, the neuroimaging discipline uses techniques such as EEG topography for brain mapping. In ophthalmology, corneal topography is used as a technique for mapping the surface curvature of the cornea. In tissue engineering, atomic force microscopy is used to map nanotopography. In human anatomy, topography is superficial human anatomy. In mathematics, the concept of topography is used to indicate the patterns or general organization of features on a map, or as a term referring to the pattern in which variables are distributed in a space.